Hello and welcome to 4.7. I hope you remember how to complete the square. That was a super fun unit the first time we had it. Guess what we're going to use today? That's right, we're going to solve quadratic formulas by completing the square. Let's get into it. So in order to complete the square, we're going to be using our perfect square trinomials. So we're going to do a quick review of those. So if we look at this first one right here, you've got a 4. Normally to factor this, we would take multiples of 4, find two multiples that add up to give us this. We can, of course, quickly figure out that it's 2, and then 2 times 2 is going to give us this 4. But if you notice that if we take the half of this number, square it, and we get this number, that's kind of how we know that it's a perfect square trinomial. When that happens, we factor it by 2, x plus 2, and it's times x plus 2, or x plus 2 times itself, which is also equal to x plus 2 squared. So that's kind of important because once we get that square, we actually have a mechanism to solve that in an idea of a quadratic equation. We can just square root both sides and then we'll have an answer. So this is kind of the point. If we can get to this part right here, then we can solve the equation that we're working on. So a couple of review examples for solving perfect square trinomials. I can look at this one right here, and because I know that it's a perfect square trinomial, there's a pattern. I can just divide that by 2, and I quickly know that x minus 10 squared is going to be an answer. So same thing here, got x minus 7 squared. Now remember, this only works for perfect square trinomials. This is not factoring all across the board. It's just these specific ones that we're going to be working with. And in our future problems in this section, we know that they're going to be perfect square trinomials because we're going to choose the values that this number becomes. So we're obviously going to pick the right value. So last but not least, look at what half of that number is, x plus 8 squared. So there's a quick review on factoring perfect square trinomials. Okay, so what are some of these problems going to look like? These first two examples are really great examples of what we're looking for because they're a little arbitrary and not likely to happen normally. But if we look at that, we've got a perfect square trinomial. So we can factor that. We've got x plus 7 squared equals 4. And this is actually what we're looking for. So once we have a situation where it's blah, 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 something squared equals a number, we have a mechanic to fix that, or a mechanism to fix that, or to solve it. So we're going to take the square root of both sides. So now we've got x plus 7 on one side. We have plus or minus 2 on the other side. We took the square root of 4. So then we move the 7 over. We have x equals 7, negative 7, plus or minus 2. So then we have one case where x equals negative 7 plus 2, negative 5. Then we have another case where x equals negative 7 minus 2, which is going to be negative 9. So that is our answer for this one. We've got our two answers, negative 5, negative 9. So for number 2, again, we've got a perfect square trinomial on the left. So we can factor that, say x minus 3 quantity squared equals 20. Again, we can square root both sides. So now we have x minus 3. And 20 is not a perfect square. So we're going to have to kind of play with that one a little bit. I know that 4 is a perfect square, so we can pull 4 out of that. So x minus 3 is equal to plus or minus square root of 4 times square root of 5. So then we're going to move our 3 over, and we're going to have x equals 3 plus or minus 2 square root of 5, because square root of 4 is negative 2. I'm sorry, it's just 2. So then that's our answer. It's our complex answer, but hey, it's our answer. Okay, here we go. So what do these things look like? So we're going to solve this by completing the square. So we've got our steps over here. We've got our example over here. So let's try it out. So step 1, rewrite it as ax squared plus bx equals c. So basically, we're moving this thing over here because we want to control what number that is so that we know that it's a perfect square trinomial. So we've got x squared plus 8x equals 34. So now we're going to complete the square right there. So hopefully you remember a little bit about completing the square. First, we got to find the right number to add and subtract. The way we do that is by looking at this number, dividing it in half. So we've got 8 divided by 2, and then squaring it. So 8 divided by 2 is 4. 4 times 4 is 16. So 16 is going to be our magic number, if you will. And now we're going to add 16 to this side. So in the last chapter, we wanted to keep everything on the same side of the equal sign, so then we would immediately subtract a 16. We have an equal sign, so we're just going to keep it like normal algebra, and we added 16 on the left. So we've got my 34. So I'm just going to add 16 on the right so that I don't break any math rules, and we're good to go. So then my x squared and 8x come down. So we can factor the left. When we do that, it's a perfect square trinomial. So we've got x plus 4, quantity squared. We'll combine our like terms, 34, 16, so 50. So then we're, back to our ability to square root. So now we're going to square root both sides, and that leaves us with x plus 4 equals plus or minus square root of 50. Is that something nice? It's not. So we're going to divide that up into square root of 25 times square root of 2, just so we can simplify it. We move the 4 over. We have x equals negative 4 plus or minus 5 square root of 2. So I apologize for not following the steps directly, but so we rewrote this. We divided both sides by a to create, okay, so yeah, we didn't have an a, so we didn't have to worry about that, but if you have a number out in front of x, you have to get rid of that number because this whole thing doesn't work if we have a number right there. So then we did take half of b, square it, and then add it to both sides of the equation. So I'm going to highlight that. Take half of b, square it, and add it to both sides of the equation. That, in my opinion, is the hard part about completing the square. The rest of this is just like following normal math rules. It's just like normal algebra. This to me is the new, weird, and bizarre part whenever we are completing the square. So then we factor the side with the perfect square trinomial, take the square root of both sides, and then we simplify all irrational or complex solutions. So again, this is the new part, if you will. The rest of this is stuff that we should have hopefully seen before, or at least be comfortable with. Okay, so let's do an actual problem. As is our tradition, we've got all of the steps written right over here. And you can follow along those steps as I go through this. But let's see what it looks like in real life with an example on the right. So, okay, it says rewrite as ax squared plus bx equals c. So long story short, we want to take this number and we want to put it over there. The reason behind that is we want to control what number is there so we can make sure that it's a perfect square. So we'll go ahead and do that. So we've got x squared plus 8x equals a positive 34 because we added 34 to both sides. So then we've got divide both sides by a. That's just that we can have that x squared by itself. Ours is already by itself, so we're good to go. So here's the part that you should highlight. take half of b, square it, and then add this to both sides of the equation. So this is kind of what I like to call the hard part of completing the square, because we're essentially adding this random number to both sides of the equation. So last time we did this, we added it and then we immediately subtract it on the same side of the equation. So we're doing the same process, but since we have two sides of the equation, it's easier to just add it to both sides of the equation and we're good to go. So it's the same concept, but it just looks a little bit differently. Either way, so that random number I talked about is going to be half of b. So that's that number right there. So we're going to take 8 divided by 2 and then squared. And that's what we're going to add to both sides. So let's see here. That equals 8 divided by 2 is 4. 4 times 4 is 16. Okay, so that's going to be our number that we add to both sides. So our equation is going to look like we just got our x squared plus 8x. So now we're going to add our 16 to this side. And because we added 16 to one side, we need to add 16 to the other side. So now that allows us to take this and we can factor it. So based on our patterns that we talked about above, that's going to turn into x plus 4 squared equals, and we're just going to combine these two terms. 34 plus 16 is 50. Okay, so let's see here. Where are we? So factor the perfect square trinomial. That's what we did there. Take the square root of both sides and solve for both cases. So this should look like a problem that we've done before. So we're just going to square, we'll change colors. We're just going to square that side. So then we're going to have x plus 4 equals, so 50 is not a perfect square, but 25 is. So we can rewrite that as plus or minus square root of 25 times the square root of 2. So then we've got plus or minus the square root of 25. 5 times 5 is 25. So we've got 5 square root of 2. Haven't done anything to the left side of my equation, but we need to solve for x. We're going to move the 4 over. So we're going to have x equals negative 4 plus or minus 5 square root of 2. And that is our answer. So again, it's not terrible. It's kind of like the problems we've been doing, but this part right here, the step 3, is the new part. It's the completing the squares part. So this is the part I want you to highlight, and this is the part that I think we might have the most trouble with. So how do we get through that? We practice. Okay, first practice problem up. Step 1. This guy is in our way, so we're going to move him over to the other side. So we're looking at x squared minus 18x equals negative 56. So then we need to figure out how we're going to complete the square. So that is going to be 18 divided by 2. And then we're going to square it. So 18 divided by 2 is 9. 9 times 1 is 81. So 81 is our magic number that we're going to use. Okay, so we're going to have x squared minus 18x plus 81. So I hesitated there because this was a negative sign, but it is plus because when it squares, it turns positive anyway, so whatever. Okay, so we added 81 equals negative 56, and we have to add our 81 to the other side to make sure that we don't break any math rules. So from there, we can factor this side. So we've got x minus 9 squared. And then we need to combine like terms on that side. All I can totally do this in my head. 81 minus 56. 25, totally. Yeah, 25. That's convenient. 25 is a perfect square. So when we take the square root of both sides, we are in business. So we're going to have x minus 9 equals plus or minus square root of 25 is 5. So now we're going to have x equals 9 plus or minus 5. We added 9 to both sides. So that means that x equals 9 plus 5, which is 14, as well as x equals 9 minus 5, which is 4. So if we want to be super cool and awesome and make it look all pretty, x is the set of 4 and 14. Oh, that's just terrible squarely bracket, but whatever. Okay, so when we start looking at number 4, hopefully you notice that this is the first time that we have a number in front of our x squared. So remember, we can't have that, so we're going to have to divide that out. But when you divide it out, if you divide this one by 2, number 1, you have to divide the entire side of the equation by 2. So we got to divide this thing by 2, as well as anything you do to the left side of the equation, you have to do to the right. So we're going to divide this side by 2. Long story short, divide everything by 2. Everything. Okay, but that's fine because all of our numbers are even, which they're evenly divisible by 2. So we've got x squared minus 8x equals negative 15. Perfect. So now we need to know what we're going to add to the equation to complete the square. So to do that, we're going to take negative 8 divided by 2 and then square that whole thing. 8 divided by 2 is 4. 4 times 4 is 16. So that's what we're going to use. So we've got x squared minus 8x. And then we're going to add 16 equals negative 15. And we have to add 16 on that side as well. So then we factor the left. That's going to be x minus 4 squared equals 1. That's going to make math a little bit easier. So we square root both sides. What we have left over, we have x minus 4 equals plus or minus 1. Remember, square root of 1 is 1 because 1 times 1 is 1. So there you go. Okay, 4 goes over. We got x equals positive 4 plus or minus 1. So we've got x equals 5 and x equals 3. So again, to be super cool and fancy, x equals the set of 3 and 5. There you go. Well, you know it's not a good day unless you have fractions involved, right? So we've got a 4 here. The reason I know that fractions are going to be involved, when we divide everything by 4, this is not easily divisible. So here we go down that rabbit hole. So we're going to divide this by 4, which will be no problem, this by 4, which will be a little hairy. But that's okay. We're not afraid of fractions. 8 divided by 4 is 2x equals negative 3 over 4. We're just going to leave it in a fraction, and that's fine. It's fine. Anyway, so we need to figure out what to add in order to complete the square. So we're going to take negative 2 divided by 2 and then squared, which equals 1. 2 divided by 2 is 1. Negative 1, whatever. Square it. It's positive 1. So again, 1 is easy to do math with. I like that. Minus 2x. So we're going to add 1 to that side. Then we have negative 3 over 4. And we're going to add 1. And I'm going to rewrite my 1 just automatically as 4 over 4. Because I know I'm going to have to add those fractions later on. Remember, any number over itself is just a fancy version of 1. Okay, so now what do? We factor the left. So we're going to have x minus 2, just kidding. We're going to have x minus 1 squared equals negative 1. No, just kidding. positive 1/4. So if I take 3, our negative 3 plus positive 4, we have 1 left over on the positive side, so we have 1/4. Okay, square root both sides, which this is the same as square root of 1 over square root of 4, which is the same as 1 over plus or minus 2. So what we're going to have x minus 1 equals plus or minus 1/2. That's not too bad. We can deal with halves. So we're going to move the 1 over to the other side. We have x equals 1 plus or minus 1/2. X equals 1 plus 1/2, or 3/2. And then we have 1 minus 1/2, which equals 1/2. And we can do our little set notation. Woo! See, fractions aren't that bad, right? Okay, let's try another one with fractions. So we've got a 3 here that we have to deal with. We have an 8 here that's kind of in our way. So we're going to divide everything by 3. And then we're going to move this over to the other side of the equation. So when we rewrite that, x squared plus 10 over 3, really? 10 over 3x equals negative 8 over 3. Okay, so I get it. This is going to get fun. Anyway, but we're going to follow the exact same process. We're just going to have fractions involved. So we need to figure out the thing we are going to add to complete the square. So we're going to do 10 over 3. We just need to divide that by 2 or times by 1/2. And then we need to square that. So we're going to have 10 over 6 squared. This is getting... Yeah, okay, so 10 over 6, got it. 10 over 6, we can reduce that before. That's what was messing me up. I didn't really want to deal with 100 over 36. But if we reduce 10 over 6 first, we can say we've got 5 over 3, because we can pull a 2 out. So we have 5, 3. We square that, we have 25 over 9. Okay, that's not terrible. We can deal with that. Okay. So we're going to take x squared plus 10 over 3x plus 25 over 9 equals negative 8 over 3 plus 25 over 9. So using some of the patterns from the beginning of this chapter, I know that I can just take half of that, and that's going to be my number. So we're going to do x plus half of that is our 10 over 6, which is also 5 over 3. So x plus 5 over 3 squared equals, so now we need to add these two together. So if I were to do that, I would have to change this fraction to over 9. So 8 times 3. So I'm going to multiply by a fancy version of 1. So we're going to have negative 8 over, just kidding. We're going to have 24 over 9 plus 25 over 9. So we're going to have 1 over 9 left over. So that's not too bad. So we got 1 over 9. That's convenient because a lot of our square roots are going to cancel out. So I'm pretty happy about that. So we got x plus, I'm sorry, we're going to take the square root of both sides. So we got x plus 5 over 3 equals the square root of 1 over 9. So that's going to be plus or minus, square root of 1 is 1. Square root of 9 is 3. Okay. So now we've got x equals negative 5 over 3 plus or minus 1/3. So that means that we've got x equals negative 5/3 plus 1/3. So that would be negative 4/3. Then we have negative 5/3 minus 1/3, which would be negative 6/3, which is also equal to negative 2. So we've got x equals negative 4/3, comma, negative 2. Whoops. Squirrely bracket. So there you go. Yes, fractions make things more complicated, but you follow the same process. Okay, let's try these next two. So they're getting more and more complicated. So we've got this guy over here and this guy over here. So we just need to move him over, and let's do it. So after we do that, we've got x squared plus 16x. So we're going to add 21 to both sides. So that's going to equal 21 minus 5, 16. I knew that. I was just testing you. Okay, so now we need to figure out what our b is going to be, or what our number we're going to add is. So we're going to take half of 16, 16 divided by 2, squared. So that's going to be 16 divided by 2 is 8. 8 times 8 is 64. So that's what we'll do. X squared plus 16x plus 64 equals 16 plus 64 on both sides. So we factor the left, we get x plus 8 squared equals 16 plus 64 is 80. So now we're going to take the square root of both sides. So we've got x plus 8 equals square root of 80 is not an easy thing to do. But we can do square root of 16 times square root of 5. And that would simplify to plus or minus 4 square root of 5. Okay, so that's fine. We're going to bring our x plus 8 down. We move the 8 over. We have x equals negative 8 plus or minus 4 square root of 5. And that's your answer. Remember, that does count as 2 answers. So if we try the same thing on number 8, here we've got our 3 that is going to pose us some problems. So we're just going to divide the whole thing by 3. All of the other numbers are divisible by 3, so that is convenient. So now we've got x squared minus 10x equals 23. 23. Okay, so what's our new number going to be? We're going to take negative 10 divided by 2, which is 5, squared, which is going to be 25. So we've got x squared minus 10x plus 25 equals 23. And don't forget to plus 25 on this side. So now we're going to factor the left. We're going to have x minus 5 squared. Then we're going to have 23 plus 25, 48. X minus 5 equals the square root of 48. We square rooted both sides. Square root of 48. So again, we can take 16 out. So we can rewrite that as square root of 16 times square root of 3. So then we've got x minus 5 equals square root of 16 is plus or minus 4. Square root of 3. X equals positive 5 plus or minus 4 square root of 3. So, so again, even though we're getting some irrational answers, that's okay. The process works the same. Your answers just look a little different. So these next two, 9 and 10, I'm going to have you pause the video right now, try them yourself, and I'm just going to put the solutions up on the screen. So let's see how you do. Okay, here you go. How'd you do? So for number 9, I added, ironically enough, 9 to both sides. Got square root of 40, square root of 40. The only thing I could pull out is that 4. So there comes to our 2. So ended with 3 plus or minus 2 root 10. Number 10, it was kind of fun. I combined these two numbers first in order to make this part even. That way, when I divided by 2, I avoided fractions. So then I moved the 57 over first, divided by 2, got here, added 1 to both sides. That's fun. And then we had square root of 73, and there's nothing that goes in the square root of 73, so we just ended with 1 plus or minus square root of 73. So hopefully you got those. We're going to try these next two examples together because they might be a little complex. Let's joke in there somewhere. So we're going to do the exact same process here. We've got x squared plus 12, if I can write it 12, 12x. We're going to move that 43 over, so we're going to have equals negative 43. So then our number that we're going to add is 12 divided by 2 squared. 12 divided by 2 is 6, so we're going to have 36. So we got x squared plus 12x plus 36 equals negative 43 plus 36. So we factor the left. We've got x plus 6 squared equals negative 43 plus 36 is negative 7. I can already tell you the square root of negative 7 is nothing interesting. So we're going to square root both sides. And oh no, we have a negative sign under there. Maybe that's why they call this complex. Anyway, we know how to do that. We're just going to use imaginary numbers. No problem. So we've got x plus 6 equals the square root. We're going to say I square root of 7. So we're pulling that negative sign out. And sorry, I just randomly switched to purple, but I'm back into blue. Negative 6 plus or minus I square root of 7. We should technically have a plus or minus right up there. That's where it came from. So that's all it is. Nothing too crazy. We're just going to be using our eyes a little bit too. So let's try number 12. We've got x squared minus 18x equals negative 97. We just moved that 97 over. Our number that we need is going to be half of 18 of negative 18 squared. Half of 18 is 9, and 9 squared is 81. So now we're going to have x squared minus 18x plus 81 equals negative 97 plus 81. So we're going to factor the left. We get x minus 9, because that's half of 18 squared. Negative 97 plus 81 is negative 16. We're going to square root both sides. Then we're going to have x minus 9 equals, it's not a weird equals plus or minus I square root of 16 is 4. So that's fun. So then our 9's going to go over, so our x equals 9 plus or minus, well, we should technically write it correctly, 4i. So there you go. So same thing with 13 and 14. Try them yourself, and I'll put the solutions on the screen. Okay, How'd you do? So this first one had just a little bit of algebra that we had to do. Move the 76 over, the 16x back over here. That way we got to here. And then we had to divide everything by 4. But it all ended pretty okay. And then from there, it was just kind of a normal problem. I added 4 to both sides. Square root of 15 is nothing. So we just had I square root of 15. So my final answer is 2 plus or minus I square root of 15. 14, same thing. We had a little bit of algebra, move the 80 over. And then we had that 3, divided the 3 out. It again came out to be an even number, so I didn't have any fractions. I added 1 to both sides. Love to see it. 1's easy to do math with. Square root both sides. This thing, negative 27, is the same. Root negative 1, root 9, root 3. This 9 turns into this 3. And then we eventually have 1 plus or minus 3i square root of 3. So hopefully you're getting the hang of it. Of course, I'm going to see you in class where we're going to do a lot more practice.